If you're looking to become a data engineer, there are 7 essential skills that you need to master. Before we dive into specifics, let's first understand what a data engineer does. Data engineers are like architects and builders of data world. They design, construct, and maintain systems that manage and process data. Here are some of the key responsibilities. Designing and automating data pipelines. This involves creating systems that efficiently move data from various sources to where it needs to be. Selecting and managing data storage solutions. Data engineers choose the right databases and storage options based on the data and its usage, ensuring data accuracy and consistency. They clean and validate data to make sure it's reliable and useful. Utilizing big data technologies. They handle large-scale data processing using tools designed for big data. Now, let's explore the skills that you need to develop. Learn a programming language. Python is a go-to language for data engineering. It's user-friendly and has a rich set of libraries for data manipulation like pandas or NumPy. Start with the basics like variables, data types, loops, functions, then dive into data manipulation and numerical computing. There are plenty of beginner-friendly courses on platforms like Coursera or Udacity, etc. If you're new to programming, it usually takes roughly about 2 months to get comfortable with Python. The next step is to understand databases. SQL is crucial for working with relational databases. As a data engineer, you will use SQL to consolidate, transform, and load data. Start with basic queries like select, from, where, join clauses. Practice with databases like MySQL or PostgreSQL to become comfortable with querying and managing data. Next one is NoSQL. These databases are ideal for storing unstructured or large datasets. Get familiar with different types of NoSQL databases like document storage or the key value stores and understand their strengths and the use cases. Next, you need to dive into data structures and algorithms. Understanding DSA is very important for enhancing your problem-solving skills. This knowledge is essential for tackling complex challenges and is also often tested in job interviews. Spending 1 or 2 months on this area will prepare you well. Next, you need to dive into data integration processes. So data integration is the critical part of data engineering. It's like hidden plumbing that keeps everything flowing smoothly within an organization. Let's take a look at why we need this. We require this for foundation of data flow. As a data engineer, you will design and build pipelines that automate the extraction, transformation, and loading, also known as ETL, of data. These pipelines move data from multiple sources into a central repository, ensuring that all the necessary data is collected in one place, ensuring data quality. During the ETL process, it's essential to clean and standardize the data. This involves removing duplicates, filling in missing values, and ensuring consistent data formats. By doing this, you ensure that data is accurate and reliable, which is crucial for any further analysis. Automating the workflow. As data volume grows, manually handling these processes becomes impractical. This is where automation tools come into picture. Tools like Apache NiFi, Talent, Informatica allow you to automate ETL processes. These tools can manage large volumes of data, ensuring that data integration workflows run smoothly without any constant human intervention. Next skill that you need to acquire is to understand big data tools. As companies deal with increasingly larger data sets, traditional systems often can't keep up. This is where big data tools come into play. So this offers solutions that can handle challenges of scale and speed. Now let's take a look at why we need these tools. Handling large data sets. Big data tools like Apache Hadoop and Apache Spark are designed specifically to manage and process vast amounts of data efficiently. These tools are capable of handling data that traditional databases cannot manage due to the size and complexity. Scalability. One of the key benefits of using big data tools is their ability to support distributed computing. This means they can split tasks across multiple computers or nodes, allowing you to scale your data processing capabilities as needed. This scalability is crucial for managing growing databases without compromising on performance. Real-time processing. Many big data applications require real-time data processing where insights needs to be derived immediately as data is received. Tools like Apache Kafka or Apache Flink are designed for these scenarios. So these tools play an important role in real-time analytics and monitoring of systems. Next one is parallel processing. Big data frameworks utilize parallel processing, a method that breaks down larger tasks into smaller independent tasks that can be processed simultaneously. This not only speeds up data processing but also optimizes the use of computing resources. So by leveraging this technique, tools like Spark can handle complex computations more efficiently, making them ideal for tasks such as data transformations, machine learning model training, and large-scale data analysis. Dive into cloud computing. Cloud computing has revolutionized data engineering by providing flexible, scalable, and cost-effective resources. Understanding and leveraging cloud platforms is now a critical skill for any data engineer. Let's see some of the use cases. Scalability and demand. Cloud platforms allow you to scale your computing resources up and down based on your needs. This flexibility means you can start with minimal resources and expand as your data grows. Services like AWS, Microsoft Azure, or GCP offers a range of scalable options from virtual machines to managed databases and serverless computing. Global accessibility and collaboration. One of the major advantages of cloud computing is the ability to access resources from anywhere in the world. This global accessibility facilitates collaboration across teams and geographic locations, which makes it easier to share data and tools. So by mastering cloud computing, you will not only improve your ability to manage and process large datasets, but also gain access to cutting-edge tools and technologies. Last but not the least, work on projects. While theory is important, hands-on experience is invaluable. Working on projects allow you to apply what you have learned in the real-world scenarios. You will deal with messy real-world data and learn how to troubleshoot issues, which is like a crucial skill for any data engineer. Tackling these challenges will sharpen your problem-solving abilities and prepare you for the unexpected one. And you can also find larger data sets online to practice with. Remember, becoming a data engineer, it's all about continuous learning and adaptation. So always stay curious and keep exploring. If you find this guide helpful, don't forget to give me a like and subscribe for more content like this.